Hello everyone and welcome to Microsoft SQL. What is a database? A database is a collection of data structured and organized in a certain way. One database is made of tables. Each table is a 2D array having a set of rows and columns. Each row is one record within the table, one item. Each column is one parameter or variable. SQL is a relational database where different tables are connected via what is called primary and foreign keys. We will explain it afterwards. A row that represents a record of information in one table can be connected to another row within a different table when both have a common identifier, of course. That identifier would be called the primary key in the table it belongs to, and foreign key in the other table where it acts as an ambassador or representative to the value that is in the other table. Let's try to break it down and make it simple. Products. In the products table, which is one table within the database, we're taking as an example, we can call the database store, for instance. We have multiple rows in this table. Each row is one item in the products table. The item have different features. The features are different columns you see on top, also called fields. For each field, you have a different value for each item. For example, item number 2 on the serial number field to the left is the CPU product of product type electronics. Release date 2018, weight is 0.4 kilograms, and the price is $60. Item 2 is one record within the table, one product among all other products. As a foretaste of how SQL works, the query in the middle retrieves all records from products, where product serial number is equal to 1274. In such case, one row meets the criteria, which is the second row. The where clause in the select command defines the condition that a record needs to meet before it can be retrieved by the query. Customer table. In this page, we see another table named customer. The query in the middle filters this table to withdraw all records or customers having a birthday greater than January 1st, 1988. In other words, all the customers born after that date will be retrieved from the table, as you can see in the subtable below, which is the result of the query. Both customer and products table belong to the same database, and we're gonna link them logically through a third table we will call purchase. A customer having a name, a birth date, a serial number, ID, as an example, will purchase one or multiple products in the same manner. One product type can be purchased by multiple customers. So it is a relationship of many to many. And this is why we call it a relational database. The purchase table will have a purchase serial number and will connect customers to products and define the quantity of one or multiple products being purchased. That's why we need primary and secondary keys. So what is a primary key? In table customer serial number is the most unique value within customer table. Two customers can never have the same customer serial number, so it becomes the primary key or unique identifier for customers. In products table, the most unique field is product serial number. Usually, it is a part of the numerical value of the barcode which uniquely identifies a product type. The complete barcode uniquely identifies one piece, of course, instead of one type of products. The purchase table below has the following fields. Serial number, which is the first one to the left, is an auto increment that is added one after each line. Purchase serial number, which is like the number of a voucher or a receipt. The quantity of the product that is being purchased. Product serial number and customer serial number. Now the product serial number and customer serial number are both called foreign keys because they don't originally belong to the purchase table. They reference the primary keys in other tables, namely product serial number in the products table and customer serial number in the customer table, where they are designated as primary keys respectively in products and customer tables, where they originally belong. This is why we call SQL database relational. We cannot cram all the information of purchase, products, and customer in one table. That's why we have the foreign keys representing the information of products and customer in purchase, so that when querying about a purchase, we can get the total info of a customer by using the customer serial number as a key to access that info in the customer table. How to create a table? We create a table using the following script as an example. Create table products. Serial number is big int, which is the data type. Big int means a long integer. Identity 11 means that it is an auto increment number. Each time we add a new row, it will be added by 1. Product serial number big int. Unique means that there should be no duplicates for this value, and it is the primary key for the table. Product name and varchar 30, meaning it contains both numbers and characters of a maximum capacity 30 characters. Not null means it cannot be null when we first insert a value. It should always be filled. It's not like we can insert a row and then update it afterwards. Product type, the type of the products, also in varchar 30. Product date, a date time data type. Product weight, a float value, which means it is a real number. And finally, product price, money. Money is like float, except the formatting is .00 at the end. It has the formatting of a money value. Customer, the same thing, the same concept. Table purchase. Also create table purchase, serial number big int identity, purchase serial number, etc. But what is unique about this table, you have product serial number and customer serial number. They are foreign keys. It means that they are referencing products and customers within other tables. So product SN is a foreign key in this table, which is purchase, but it's referencing product SN, which is another field having the same name within another table, which is the products table. So product SN is the primary key in the products table being referenced by product serial number locally within the purchase table. Of course, it's not mandatory to have the same names for primary and foreign keys because these are different fields in two different tables. But it's not required, but it's recommended so as to keep track of both of them. Same thing for customer SN. It is a foreign key here, but it's referencing the customer serial number within the customer table where it is primary key over there. So it is a foreign key within this table, but it is like a representative, an ambassador for the customer table. So when we reference or when we go look for a customer, we can refer that made the purchase, we can refer to the customer serial number in the purchase table and go to the customer table to look for the customer information over there. As an example, here you have a customer having a specific name. He made a purchase to a product which is CPU. So this product is referenced by the product serial number, correct? Which is CPU or RAM. Okay, this is a RAM here, but you can consider it as a CPU. It's okay. And for the customer serial number, it is customer 800, not showing in this table, but it is a customer having a serial number within this table. So we can go look for a purchase serial number and the customer name that bought that purchase. Also, what type of product and the specs of that product being purchased by referencing the serial number of product and customer serial number. In order to make such query, this is how you can do it. Select let's say here I'm multiplying the quantity by the product price to get the total price of the purchase for this customer. Select PU. PU is, by the way, called an alias. Instead of writing the complete name of the table, we refer to the table by the alias. So select pu.quantity times pr.productPrice and c.customer name. We're selecting only two fields here. From purchase PU, inner join, we're joining multiple tables that have primary and foreign keys. Inner join products PR on pr.productsn is equal to the purchase.productsn. So the product serial number in the products should match the product serial number in the purchase, which makes sense, so that we would get the correct item. Inner join customer C on c.customer serial number equal purchase.customer serial number. And this is how we can get the customer name from another table and the total purchase that has been made. We can also add a condition to this query, meaning that only get me PU quantity times pr.productPrice as total payment, meaning that I've created a new field called the total payment, which will hold quantity times the product price, and get me also the customer name from purchase PU inner join. Inner join means get me the intersection of these tables. Products PR on pr.productsn equal pu.productsn. Again, PR is the alias for products. Inner join customer C on c.customersn equal pu.customersn, where customer serial number is equal to purchase.customer serial number, where the customer serial number in customers is equal to 100. So it will get me where the customer serial number is equal 100, which is a specific person, specific customer. It will get me for it the name of the customer and the total purchase. And the result will be the following: total payment next to customer name. Of course, total payment, it's like a field we invented in order to house the product between the payment or the price and the quantity next to customer name. Okay, at first we need to download Microsoft SQL Server 2016. For my case, you can download another version in yours, Service Pack 3 Express. Once it is downloaded, you open up the folder to see or to run the setup, or you can run it immediately from downloads. Once we start running it, we need to wait until the setup is completed. Okay, at first we need to pick basic installation, accept. You can change the directory or folder of installation and then click install. Of course, it will need more time than what you're seeing here because it is an accelerated video, so that we won't wait the entire installation to finish. At first, it downloads and then it installs the setup. Once it is installed, we need to download and install Microsoft SQL Server Manager, okay? Which is the platform where you can write queries, we can create new databases, new tables. Okay. So it will redirect me to a link where I can download and install Microsoft SQL Server Manager. So the SQL Server is one thing, which is the main engine to run SQL queries, but the Server Studio Management Studio, rather, that's its actual name, is where I can run these queries, I can write these queries, I can create tables and manage the tables. Okay, it is my interface to the SQL Server. Okay, once it is installed, you can run it. Okay, the server name is the actual station name / SQL Server Express, which is what I named. I left it the default value. Okay, you can name it something else. Now, once we are in, to create a new database, right click new database. Okay, so I'm gonna name it movie studio for example. Okay, you can change the options, make it shrink automatically, for instance. Okay, shrink automatically means it compresses on its own without you interfering. Okay, not much advisable because it can degrade the performance of access to the database. Once it is created, you can go down to tables and create a new table. So right click on tables, new table. In the table, I will create the fields, which are the columns, in other words, starting from, let's say, movie serial number. I can define the data type. Data type means what type of data movie SN will store. So in this case, it is big int, meaning a long integer, the same thing as long in Java. Okay. You have movie name, which would get a data type, and varchar, meaning numerical varchar, numbers and characters. It can hold both numbers and characters. And we need to define the length of this varchar, meaning let's say 30 characters max, 40 characters max. Okay, allow null, meaning that the value can be null when you first insert this record. Okay, you can update it later. But for the movie serial number, it cannot be null. It should always be a real value, correct? And we can make the movie serial number an identity type. Identity means it auto increments every time I add a value. Okay? Movies. Okay. In order to create a new database, you go to database directory to the left under the server name, which is in my case cstation /SQL Express. Right click new database, as simple as that. I will name it, let's say, options, auto create statistics, auto shrink, false, shrinking means to compress the database to lower its size on the hard drive. Okay, this is what shrinking does. You have other options that you can tinker with to cater after your own special needs for this database. Parameter sniffing, snapshot isolation, etc. MyDB 24, let's say, and this should work, you know, yeah. Okay, and you have a new database. Okay, in order to delete the database, I can delete it from here or use a query, which is right click, new query. You simply type drop database mydb24, which is the name of our database, and after running it, it will be deleted. So let us check. If we refresh the databases, MyDB should no longer exist. Pending. It is currently in use. Let us use another database. So use molstore and drop database MyDB24. Refresh, and we no longer have this database. Now in this database, we already have one table, which is dbo.products within the database called molstore. But let us create a new table. So right click new table, or I can create it via a script. Let us create it via a script at first. So right click new query on the database, of course. We're gonna create a table called customers. So this is again a database about a store that has one table for products so far. We're gonna check it right now, and another table for customers. So create table customer, let's capitalize it. The first field is a serial number, which is an auto increment. So the data type is big int, a big integer. Identity 1 1. This means it increments every time I insert a new value. This would be our primary key. Customer serial number, which is the serial number for the customer, not an auto increment, but rather a serial number, a unique identifier for the customer. Also big int, unique, meaning that there should be no duplicates with this value. Customer name and varchar 30, meaning a variable, character and numbers, or it can contain both characters and numbers. Customer birth, meaning birth date, that would be a simple date. Finally, customer address, this would also be nvarchar 50 this time. Okay, it can be either capital or lowercase, it doesn't matter in our situation in SQL. Okay, so I chose at first to write it in capitalized letters to draw attention to it, but it works both ways. So let us run the query. The query has been successfully completed. Right now, if I refresh the tables, you will have a new table, which is for customers. Now, for products table, I already have values within this table. In order to withdraw all the values from all the fields that are available in products, we can simply write a new query here. Select star means get me all values from all fields, from the name of the table. Let's at first also use the database, okay, so that I can make sure that SQL is accessing this database, not another one. Select star, which is an asterisk, from products, and if we run it, we get all values, all records from this table. I can do many things within this table. Let us at first selectively get values based on a condition. So I want to selectively get specific values that meet specific conditions. Okay, select star from products. I can split their lines, by the way. Okay, where means I'm writing a condition here. Where, let's say, Sn is greater than 3. If we run it, you see here the field which is called serial number. It has numbering from 1 all the way to 6. So this query will get me all records that have the serial number greater than 3. So you have 4, 5, 6. Okay. If I want to see the values all over again, all the values within this table, select star from products. So I want all the products that have a product release date greater than 2005 or 2015 rather. So select star from products where product date is greater than, and here I need to enter a string value, 2015 dash 01 dash 01. Okay, greater than the beginning of 2015, let's say. And we have all the products that have been released after the first day of 2015. Another thing that I can do is counting the number of the products that meet this criteria, that have a product release date greater than year 2015, first day, first month. So you write select count star from products where product date greater than 2015 0101. This will give me the number of such products that have a release date meeting this criteria or condition written after where. And you have number 3. I can also as well pair two conditions together, meaning what? Let's say select star. Okay, let me see all the products again. So I want to get all the products that have a product type containing the name electronics or starting with electronics. Okay, electro. You don't need to even write the entire name of the value. And as well, having a weight greater than or equal to 13. By the way, I need to change these values. I did not fill them. Select star from products where product type like meaning it starts with it starts with the word electronics. Let us run this at first, and you have all the records or rows that have a product type starting with electro. No need again to write the entire string, but I want to also pair it with another condition. So not only I want the product type to be like electro, but also, which is and, okay, product weight greater than or equal to 13. And hence we've gotten only the one row which meets both of conditions, both of these criteria. Okay, so here I have two conditions. I can write them this way, and both of the conditions need to be true so that the records will be returned. Okay, so the records or rows that meet both of the conditions, so the first one, which is product type like electro, it starts with the word electro, no need to write electronics, and at the same time the product weight is greater than or equal to 13. Both of them need to be true so that the condition would be true. Now I can change this condition to, instead of and, or. Or means either of the conditions need to be true so that the row would be returned. So all the rows that meet either of these two conditions, so if the records meet one of the two conditions, either the first one or the second one or both, it's like you're adding one condition to the other. So you know, if you have 1 and 0, 1 plus 0 give you 1. 0 plus 1 give you 1 as well, meaning if the first one is false, the second one is true, it give us true. First one is true, second one is false, it would be 1 plus 0, it give us true as well. And 1 plus 1, meaning both of them true, will give us true as well. Because in binary, 1 plus 1 gives you 1 as well. And here you've gotten all the rows that meet either of the two conditions. Now let's say I want to get the product where you have the maximum serial number. Select where products SN or product serial number is equal to, and here I can write another condition. Select max product serial number, which is different than the serial number that increments within the table, by the way, where product SN is equal to select max, the maximum value of product SN from the table, from products. That's the name of the table. And you get the row or the record that has the maximum product serial number. Now, another way to put it, so let's say I need to select the products where, let's say, product name is different than a certain name, or let's say a product date is not this product date by negation. So select star from products where product type is different than, this is how I write is different than, electronics. And you've gotten everything except electronics. Okay. Now let's say I want to update the values of weights which are not correct here. I forgot to enter the values for the weight for these two different products, 2 and 3. So how to change that? I simply type update products, set product weight equal 10, where product name equal CPU, and let's run the query afterward. Select star from products to check if it had changed. CPU weight has changed to 10. Let's say I want to delete a specific value. So I want to delete Castrol here. How to actually do that? You simply type delete from table, which is the name of the table, delete from products, where either the serial number or the product serial number. Okay, so I'm going to use the latter, where product SN is equal to 9322. Okay, and then let's select from products to check whether it has been deleted. So you're going to notice that this row will go missing. And you see we no longer have Castrol. The serial number, which is auto increment, has been changed. The value that is 4 has become missing right now. Also, let's say I want to get the sum. Okay, let's get back to the original table. And I want to get the sum of all the prices, or the price of all the products within this table. So to get the sum, select sum of product price from products. Okay, if I don't type any condition, it will add all the product prices together, and you have 160. Now I can make it to go with a specific condition so that it would run only the sum of specific products, not all of them. So let's go back to the original table, select star from products. So I will add up the product price of only the electronics, without lubricants, power, things like that. By the way, I should have added the number of items within the store, which is missing right now. Okay, so select sum for product price from products, where product type like electronics. And let's see the sum of the products that are electronics. It should give me 55, 15, 70. Plus 30, 100. And you've gotten 100 as an answer. Select star from products. Now let's insert a new value within the table. So let's say I want to insert a new type of product. So you simply type insert into products, and I need to specify the fields where I need to insert the values. For me, the first field is untouchable. Why? Because serial number is auto-increment. I cannot actually change it manually. It changes automatically. Each time you insert a new record, it increments automatically by 1. So I need to only list product features or fields that are changeable. Product SN, product name, product type, product date, product weight, and product price. Okay, you close the parentheses, then you go and open up values, and these will be the values respectively for all fields listed within this insert function. So values for product SN, let us insert a random value. Product name, plastic tube, okay, plastic tube. Product type, okay, and this is a string, so it needs to be delimited by single quotes. Plastic. Product date, this also within a string, so 2017 06 09. Product weight in kilograms, which is a numerical value by the way, is 10 kilograms or 20 kilograms. And the product price is $19. So let us check this new value. I will remove the insertion function and select star from products. You see, this is the plastic tube. Now let us say I need to get specific fields, not all of them. I'm not interested in getting all of the fields from product serial number all the way to product price. Select product name, product weight, and product price from products. So you will get only these three fields. We can add something to that, which is sort or arrange. It is actually written order by. I want to order it by product name. So these values will be ordered alphabetically according to the product name. Let us check it. And you have Arduino at first, CPU, Firewheel, plastic tube, RAM. Of course, also the values and the product price need to be reordered. So the entire row is resorted based on product name. If I order it by product weight, it will give me the product from the lower weight or the lighter weight all the way to the heaviest one. So you get the plastic tube at the bottom, and Arduino, of course, the product weight here is incorrect because it cannot be 0, but as an example. Now, if I write here descending, you see, descending means I flip the order from the heaviest to the lightest. Now, if I use the product name to order these products and I list descending as a keyword, what will happen is instead of starting from the A letter all the way down, it will flip the order as well. So let us order by product name again. And Arduino this time would be at the bottom. Why? Because it starts with the A letter because we reverse the order. Now we're gonna use or add primary keys to customer table and products table. At first we need to note that for the tables that would become primary keys, they need to be not null. Their type, data type, should not be null. Now for customer serial number, this would be the new primary key. It is not null already. I need to change for the products table, the product SN, which is null, needs to be changed to not null. In order to do that, alter table, products, alter column, product serial number, big int, which is its original data type, but I'm changing it to not null. If we refresh it, we're gonna see that the column has become not null. Now I need to add the primary keys. Alter table, customer at first, add constraint, customer PK, which means customer primary key, customer serial number. Okay, we've added the primary key to customers. So if you refresh column, you have the key symbol in customer SN. We need to do the same thing for products, which would have product SN as the primary key. Alter table, products, add constraint, products PK, primary key, and we define the column that would become the primary key, product serial number or SN. Let's execute. If we refresh the table, product SN has become the primary key. Okay, now we have a purpose for doing that, because we're gonna create a new table called purchase, which would join both tables, customer and products. So you would have the ID of the customer embedded within the purchase for a specific product, and it also will have the product ID for that purchase, so that we can link different information from different tables together. Let's create the new purchase table. Create table purchase, serial number, big int, identity, which would be an auto increment, and a primary key for this current table. Purchase serial number, big int, not null, quantity of purchase, integer, product serial number, big int, which is taken from the products table, and customer serial number, big int, also from the customer table. Then foreign key, product serial number, references, or in other words, where does this key or this field come from? Foreign key means that this product serial number is foreign here locally, but it comes from another table where it is actually the primary key of that table. So foreign key, product SN, references, products, product SN, foreign key, customer SN, references, customer, customer SN. Again, as a reminder, this product serial number is foreign here locally in purchase table, but it comes from the primary key having the same name in the products table. The same thing for customer SN, where it references a primary key in the customer table, also carrying the same name. If you go to the purchase table, we need at first to refresh the tables. You see here the serial number, okay, it's primary, product SN and customer SN are foreign keys locally. Within purchase, they are foreign. Why? Because they derive from keys from fields that belong to other tables. So product SN is foreign in purchase. While it is foreign in purchase, it is actually the primary key within products table. Same thing for customer serial number. It is foreign here, but it comes from a primary key located in the customer table, which is the customer SN. Here it is primary, but in purchase it is foreign. To link those two tables together, product SN is foreign here. It's linking the product's serial number, which is the primary key of the products table. The same thing for customer serial number. If we run customer, you see the customer table is empty. We need to fill it with some values. Insert into customer. Let's forget about the serial number, which is auto increment. We will fill customer serial number, customer name, customer birth, customer address, values, customer name, birth, address, whatever. We will also insert other values to John 97 for the address, a random value. We will check at first the values and customer. Okay. Now let's start inserting some values in the purchase table. So, to get all the fields that are in purchase, purchase SN, quantity, let us insert some values. So insert into purchase, purchase serial number, quantity, product SN, customer SN. Values, okay, for the purchase serial number, whatever, quantity, let's say 3. Product serial number, we will leave it for now, but customer SN, I know that they are numbered from 1 to 3, correct? Okay, let us hold it for a second. I've cut it temporarily. Okay, let's check the products to get a serial number among the products. Product SN 23432 for the RAM. Let's go back to the main query Let's remove this for a moment. Insert into purchase 234 32. We've inserted a new value into purchases. So if I select star means everything from purchase, we have a new row. So how do we get the actual name for the customer and the actual product name for the product serial number within this purchase table? Alright, I took the liberty to fill up the three tables, whether the products, the customer, the purchase. Of course, within the purchase, the product serial number needs to be an actual product within the products table. The same thing for the customer. So the customer, you see here, customer serial number is 100, 300, 500. You will see the same serial numbers within the customer table. These are actual customers having name, having birthday, etc. The same thing for the products. If I look at the customer table, you will see 100, 200, etc. belonging to customers. So you look at customer, we have 100, 200, 300, 400, 500, 600. These are actually people. Within the purchase, there's no problem of having duplicates because the same customer might have purchased different products. So it's a relationship of many to many. Many customers can purchase many products, but each customer is supposed to have a unique customer serial number. So the purpose of that is being able to join multiple tables together to extract information from customer, products, and purchase, with the common denominator is being the purchase. Okay, so to give you an example, if we go to purchase, I'm interested in getting the extract for serial number. Instead of product serial number, I want the actual name of the product. Same thing for customer SN. I want to get the real name of the customer, not the serial number, quantity of the purchase, and perhaps the purchase serial number. So how to join multiple tables together to get this outcome? Let's get values from the three tables at the same time, meaning I want the customer name, the product name from a specific purchase. And as you know, purchase does not contain customer or product name. We only have the serial number. That's why we need to link serial numbers with their corresponding tables, where product SN, customer SN are the foreign keys for respectively the products and customer tables. So select. We're going to use also alias. So instead of using the entire complete name of the table, we're going to use a keyword or a nickname for the table. PU for purchase dot quantity, comma, PR, which stands for product, dot product name, and C dot customer name. From purchase PU, purchase has been replaced by PU instead of using the complete name each time. Inner join, we're joining multiple tables. Products PR on PR dot product serial number equal purchase dot product serial number. Inner join C customer C on C dot customer name or customer serial number, I'm sorry, equal purchase dot customer underscore serial number. Okay, let us check it. Great, you see, instead of getting serial numbers, we have gotten product name and customer name, also along with quantity. Okay, now this is what I can also do. I can also add a condition on pr.productsn equal pu.productsn and pu.productsn or pr.productsn is greater than 2020. Let us run it. You can have multiple conditions paired together. Okay, let us remove this condition. Okay, I can add to the condition where pu.quantity is greater than 2. Let us check it. Or within the inner join, you can add to the condition or to the products on pr.productsn equal pu.productsn and pr dot product serial number is greater than 4040, let's say. So it will only get me all the records, quantity, product name, and customer name where the product serial number is greater than 4040. If we look at it, you will get the serial number for RAM plastic tube fire wheel greater than 4040. To confirm it to you, I will cut this query. Okay, you see, we've gotten the same values. Now another interesting thing that we can do to alter this query. So instead of pu.quantity only, I want to get the price times the quantity. This is what we can do. Select pu.quantity times pr.product price next to product name next to c.customer name. pr.productsSN equal pu.productsSN. Let us remove the other condition. I'm getting the quantity times the product price for each of the product name and customer name. For the first field, this is the actual price for each purchase, but we need to name this column as total price and you have total price. Another interesting thing that we can do, let's say you want to add up all the purchases, we want to get the total purchase, okay, the total everything. So what we need to do is select sum for all quantity times their corresponding prices as total price, but we need to remove the other fields because they no longer correspond to that query, given the fact that you're getting total price for everything. It's no longer selective by product name or customer name. From purchase pu, inner join products on pr products, on pr products sn equal pu products sn, inner join customer c on c.customer sn, pu customer sn. Okay, and you get the total price. And by the way, another thing, we can of course concatenate the sum to dollar. So select concat, I think, this expression and the dollar sign, and we have the concatenation of the money, the total price, and the dollar sign. Usually the dollar sign is right behind the price. Okay. Also another thing, of course, we can do is adding up only the products that meet a certain criteria. Let's say, so I want the sum of all purchases for specific customers where c.customer.sn equal pu.customer.sn to link both tables, and pu.customer serial number is greater than 300. This will change the final outcome, okay, because we have extracted only those who have a serial number ranging above 300. So basically, within the inner join c.customer.sn equal pu.customer.sn, which is necessary, of course, because we are linking those two tables together on the premise of primary key and foreign key. I want to add another condition, which is c.customer name is like, meaning that within the string of customer name, we have the letter O. So if we run it, the value has changed. What I desire to add also is that you can tamper with that. Let's say I want to get only those starting with letter J. So you'd have only purchases for those whose names start with J, capital J basically. Alright, let's go back to one of the tables, either customer or products. To show you other functions. Let's say I want all the customers having a serial number between two values, between 100 and 400, let's say. Select everything from customer, where customer serial number between 100 and 400. Usually they are included. You have all customers within that range as a result. Also, let's say I want to get the average for specific rows within a table. What do we have in customers? Let's go to purchases. I want to get the average of purchase. Okay, so from purchase, so we can get the average quantity, let's say. Average for quantity from purchase, and you can even add a condition where purchase SN is greater than 2456 and the average value among purchases that have purchase serial number greater than 2456 is 2. Because if you look at the purchases, you have values 32, 325, it's around that number. Let's also do another thing. I will create another table for products and I'm gonna copy from one table to another. Let's at first, I'll try to copy the query for the products and we will change the name from products to products new products. If we refresh the tables, you will get a copy of the products table, which is products new, except this one is empty so far. Products underscore new. You will get an empty query because we still have no values so far. So how to insert values or rows, records from one table to another, from products to products new. In order to copy rows from one table to another, insert into the target table, which is in our case product or products underscore new. We need to define the columns to which the copying will be made, because for the first field, the first column, which is the serial number, we cannot copy that. It is an auto increment. So product SN, product name, product type, product date of release, product weight, and product price. Then we need to select these fields from the other table. So select everything. Actually, we need to define the fields in our case. Let's copy them. They are the same field names in both tables. From the old table, which is products, and we can define a condition where products dot product serial number, let's say, is greater than 4040. Okay, 5 rows have been updated. Let's check them. Select everything from products new, all of these rows that respect the condition mentioned beforehand, which is product serial number greater than 4040, would be placed, or have been placed actually, within products new. Now, how to write an SQL procedure. The procedure has the advantage of simplifying executing complex SQL commands. So instead of having to rewrite an SQL command over and over for a specific purpose, we can write it within a procedure, and for that procedure we will get an input to be filled in the condition, for example. And after getting the input, the procedure, whenever it is called, it will execute all the SQL command, whether it is intricate or complex or whatever. Everything within its body will be executed each time it is called. To write a procedure, I can simply go to my database, new procedure or new query, because we can write it as a query. Or alter. Alter means in case the procedure already existed, we're gonna alter its behavior to update whatever has been written in that procedure with the new content we are writing at the moment. So create or alter procedure. We're gonna call it get. Let's say we're gonna write a procedure for the customer. So get customer name. Okay, the input for get customer name is customer serial number. This is how we insert the parameter, or we declare the parameter, the argument for the function, or in this case the procedure. At customer serial number, big int, big integer, as here we have the declaration of the arguments, and after as you have begin end. Within these two commands will be the body for the procedure. This is where we're going to write the query. Select customer name from customer, where customer serial number, which is the field within the table itself, is equal to the argument provided within the procedure. Add customer SN. Okay, let's run it. And if you go to the store the procedures within the database, let us refresh it. And now we have two procedures. One I wrote it before, and this current one. So let's try to call the procedure. Let's erase this procedure declaration. To call the procedure, usually the procedures are called from outside of SQL, usually from a software such as C#, Java, or something else. But to call the procedure within SQL, exec, the name of the procedure, which is in our case get customer name, and we need to define the value for the argument, which is product serial number is equal to 400. It should return the name of that customer. It is called customer serial number, not product serial number. So customer SN, this is how it works.